Hey everybody, we're jumping back into the 2017 MCAS. So this is the non-calculator section, and you'll notice these are in the previous format. This is the original format of the MCAS. This does not match the format of the current digital system, but there's still value in doing these problems. You can find the PDF to this document in the video description, and the idea is that you've already tried these on your own and then you're checking to see how to do them. The answers are available in the back as well, so you can check your answers for most of them, except for some of the open responses. All right, so let's get right to it. Number 20, this is towards the end of the first session. Stuart wrote the expression shown below, and we have an order of operations expression here, it looks like. What is the value of Stuart's expression? Show or explain you got your answer. So we're just going to solve this, we're going to simplify this, part A. Some scrap paper here. So I'm going to rewrite the problem here. So 16 plus h squared divided by 4 minus 4. So order of operations is going to be like, I like to write it like this, this acronym. Parentheses, exponents, multiplication, division is a single step from left to right. Addition, subtraction is a single step from left to right. Oftentimes you see people write it like this, which I really don't care for because it gives the impression that you multiply before you divide or you add before you subtract, which is dependent upon where it is in the expression. This is, I think, a much visually less confusing way of doing it. Okay, so there's no parentheses, there are exponents though, so 8 squared is going to be 8 times 8, which is 64. So we have 16 plus 64 divided by 4 minus 4. And then we don't have any more exponents. We have multiplication, division. We have division right here. So 64 divided by 4 is going to be 16. 16 plus, let's double check that. Still early in the morning. 16. I wouldn't have a calculator, so I just cheated, I guess. Uh-oh. 16 minus 4, and then 16 plus 16 is, and we're going to add subtract from left to right. 32 minus 4 is 28. So part A should be 28. In your student answer booklet, insert one set of parentheses into Stuart's expression so that the value of the expression is undefined. Okay, sure. So in order to get undefined, you typically have to divide by 0 or you have a square root. So let's start with this. So we have, this is our original. And typically, again, to be undefined, you want to be dividing by 0. So here, we can only set one set of parentheses. So we want to divide by 0. So I look for divisions right here. And I notice 4 minus 4 is 0. If I put parentheses here, I should label this part B, by the way, sorry. If I put parentheses here, this is going to make that equal 0, which means we're going to get 64 divided by 0, which is undefined. So this would make it undefined. And your explanation would be you cannot divide by 0. So I'm going to rewrite it right here. 16 plus 8 squared divided by 4 minus 4, put parentheses here. Okay. Talia wrote the expression below. This thing right here. Talia found the value of expression by using the following steps. Okay, is the value that Talia found for expression correct? Explain your reasoning. So what I'm going to do is actually solve this and then compare it to what you did. I find that to be the easiest way to do it rather than anything else. It's part C. We have 16, parentheses 16. You have to be really careful, by the way. If you're scribing anything, if you're rewriting anything from the test, make sure you check it as you're doing it and check it after you finish it. Make sure you didn't make any mistakes. It's very easy to make a mistake here. So 16 plus 8 squared divided by 4 times 2 minus 4. Okay, so let's do an order of operations. I'll write that again. PEMD, arrow, AS, arrow. Okay, so parentheses, yes, we have in parentheses. And in the parentheses, we have addition and exponents. So we're going to do exponents first. So 8 squared is going to be 64. So we have 16 plus 64 divided by 4 times 2 minus 4. Let's see if she did that first. She got that first. Okay, so, yep, same thing. And then we're going to add these together because it's still in the parentheses. It's going to be 80 divided by 4 times 2 minus 4. So we should have 80. Okay. Now we're going to do multiplication division as a single step from left to right. So 80 divided by 4 is going to be 20 times 2 minus 4. Oh, look, they multiplied first. See, this is a good example. So somebody that learned it, when they learned order of operations, they saw it like this. Okay, they would multiply first here because they would think you multiply before you divide, and that would change the value of the expression incorrectly. So that's a really good example of why this version is not very, very good, to be honest. All right, so you can already see her mistake. Then we multiply, so 20 times 2 is 40, and 40 minus 4 is 36. So the correct answer should be 36. Her answer is 6. It's much easier in a problem like this to solve it, and then step by step check with what they did, and you can see where her mistake was made. It was right here. Okay, was it correct? And no. Then you write the explanation of where she made her mistake, which is right there. Okay, last part. Talia removed a set of parentheses from her expression to create a new expression, shown below. What is the value of the new expression? So we're just going to solve this one. Okay. So I'm going to rewrite this. So part D. We have 16 plus 8 squared divided by 4 times 2 minus 4. So our order of operations again. All right, we know parentheses, we have exponents. So 8 squared is 64. So 16 plus 64 divided by 4 times 2 minus 4. And then, let's see, we're going to divide, because we have multiplication division is a single step from left to right. So 64 divided by 4 is going to be 16. So 16 plus 16 divided by, times 2. I screwed that up. Times 2 minus 4. Let's get rid of that. So we multiply now. So 16 times 2 is 32. So 16 plus 32 minus 4. And we add and subtract from left to right. So this would be 48. Minus 4 is 44. Let's just double check that. So squared, yep, 64, divide, 16, yep. And then multiply, 32, 48, 4, yep, that's right, 44. Here we just show all the steps. All right, so for that problem, we're basically just order of operations. But you can see, I think part C is probably the most challenging. I don't know why this is a part 4. Usually the fourth part is the most challenging. I don't understand what would be so challenging about this problem. Yeah, I don't know. That's a weird one. Okay, let's look at 21. It's another open response. I think this is the last one of session 1. Yeah, it is. Okay. All right, and I probably want to use a pencil for this one. Zoom in a little more so you can see. The table below shows the number of full-time employees at 8 guitar production companies and the number of guitars produced by each company last year. So this is the number of people working full-time, this is how many guitars they produced. Okay, on the grid, here we go. On your grid, create a scatter plot using the data from the table. So let me zoom out so you can see the directions there. So we're going to create a scatter plot using this table. All right, so it looks like number of full-time employees is our X value, so we're going to label this X. And then number of guitars produced is our Y value, that'll be Y. So we just plot each point, so 398. So this is, you gotta be careful here because the scale is not consistent. So this is going up by 1 for each block, this is going up by, looks like 50 for each block. And they're not all labeled. So 398, so 3 would be right here between the 2 and the 4, and 98 would be just below the 100, like right below it, so that's the first one. I'll check off each one we do. 5, 189, so 5 would be here. 189 would be right about there. 6, 235, so 6 is here. 250 is there, so 235 would be somewhere right around there. And then 8, 309, so 8 is here. 300 is here, it's going to be slightly above that. 8, 336, so it's be above that one. And then 10, 412. 10 is here, 400 is here, 412 would be right above it. 13, 494, so 13 would be between the 12 and 14. And 494 would be just below the 500. Sorry, it's hard to see that. There you go. And 18, 692. This would be right there. Okay, that's our scatter plot. It's pretty strong correlation. It's kind of hard to see with the pencil, sorry. See a little better there. On the scatter plot, draw a line of best fit. So, my ruler. So it's the line that best represents the data. So say like, it's about right. Now it doesn't always have to go through the origin. Students always have the habit of going to the origin, but in this case I think it would be. Okay, write an equation that best represents the line of fit. So to write the equation, so we're going to write in linear format. So y equals mx plus b, m being the rate of change. I'm going to use a pencil or pen now. Y equals mx plus b. Okay, so our b is going to be 0. And the rate of change, let's see, I'd say it goes about over 5 up to 100. So vertical change is 200, horizontal is 5, so 40. 40. If I simplify that, it's 40 over 1. Yeah, so I'd say m is 40. So I'd say it's y equals 40x. And that'd be the equation, so y equals 40x. Put it down here. Okay, use your equation to estimate the number of full-time employees needed if a company wants to produce 1,000 guitars. So this is a weird problem for four-parter. So y equals 40x. We're going to go 1,000 as our y value, so 1,000 equals 40x. Just put over here some more room. So 1,000 equals 40x. We solve for x, because that's the number of employees, full-time employees. We divide that, and let's see, 1,000 by 40. Let's simplify that. 25. Yeah, 25 employees roughly. So I could see one of the trouble areas of this problem would be calculating the rate of change, because if your line of best fit isn't solid, it's going to be hard to calculate. It just happens to be, when I looked at this, I was trying to find a point where it hits a grid mark, and you can see it does it right, where is it? Right about there. It's like really, really on point. So it's 20 over 500, 200 over 5, which makes it just really, really easy to calculate the slope. But I could see that being a trouble area. All right, so hopefully that was helpful, guys. I know that, I mean, for these two problems, this one you'd see digitally where you create the grid. This one is interesting too. So hopefully that was helpful. Thanks for watching, guys.